physics, electricity, simple circuits. So what did you think of these ones? Good, bad? Okay.
Yeah, but there is some concentration.
Some concentration. Not too much concentration. There's some concentration, yes. Okay. Well, maybe you can read it to me while it's opening. So, here it is. So, two 5-ohm resistors are connected in series to a 5-volt battery. What is the current? Okay, so let's have a look here. Number one, 5 ohms connected to a battery of 5 volts. And I want to know what is the current here. So I should combine these. What is the or here? 10. Yeah, so now it actually looks like this. 10 and 5. So this is just V equals V, I, or triangle. So then the I equals V over or, which equals 5 over 10, which equals 0.5 amps. That's okay to start with, isn't it?
Yes.
So, number 2. A 2 ohm and a 3 ohm are connected in parallel, and then this is connected to a 4 volt and a 2 volt cell. How much current is provided by the battery? Okay, so this one here, there's a 2 and there's a 3. And I'm sorry if this wasn't too clear, but what I meant was you have 2 cells like this, and they're a 4 and a 2 volt. So the first thing you should do is add these together using the formula 1 over or equals 1 over 2 plus 1 over 3. So 1 over or equals 5 over 6. So or equals 1.2?
Yes.
Yeah. Yes. Oh, sorry, and how did I get the... sorry, that's just the or. What did I want? The I, yeah. So here this makes 6. So again, I equals V over or, which will be 6 over 1.2, which is... So is this 5?
Yes.
5 amps is the final answer.
I do like every parallel, everyone with the 6 volt. It's like this is the same answer.
Yeah, you got the same answer? Yeah. So you said here it's 6, good, and here is 6, very good. And then what did you got the I here, and the I here, and then you add them, and you get 5 then, perfect. So you see that you have more than one way to do these, more than one way. Yeah, good. Okay, number 3. Now this again is the electric company laying down copper wire. The copper wire is 4 centimeters in diameter and 200 kilometers long. And for copper, I said to use this value. Now that should be ohm meters, not ohm meters squared. So I need to change that. How much resistance is there in the 2 wires braided together and insulated? Okay, so first, let's just do one wire. One wire. Here, the radius is 2 centimeters, and the length is 200 kilometers. So the resistance will be rho L over A, which should be 1.72 times 10 to the minus 8, times 200,000 over pi or squared. Now, it should 2.73 ohms. Okay. Now, what happens now is they have 2 wires. But here's the key thing. It says they're insulated. What does that mean? insulated wires.
They don't conduct electricity.
What exactly? I mean, they do conduct electricity because there's a current going in them. Insulated, ED, what does it mean?
Made into converted.
No. You see, I know why you're thinking this, because you're thinking the noun insulator.
Yeah.
Insulated together?
No, so you don't know this word, that's okay. I'll show you insulated. You see here, this is a conductor, but it won't hurt me because on the outside there's plastic. So I describe this as insulated.
Wow.
Now it's not an insulator, it's a conductor because the current goes through it, but it's insulated.
Why?
So covered.
It's covered. Insulated, ED, means protected, covered. So, yeah, so what? So what? So what if it's insulated? What difference does that make?
It won't give the shock.
True. So mathematically, what does that mean? Well,
It will conduct electricity inside, so we can.
I'll tell you. If these are insulated, it means there's plastic here and plastic here. So in your mind, you think about this not as one, but as two parallel resistors. Because it's insulated, it means they're separate. So it means that the total resistance, you must find it by using this formula. In the last example, they were not insulated, so the resistance doubled.
Yeah.
The resistance halved, yeah. Let's see if it halves. What do you think? Will it be halved again, or will it be more or less than halved?
More.
It'd be less than half. Let's look at what happens here. Oh wait, it's still halved. Weird. That doesn't feel right. Okay. Oh well, this question actually is a little bit different because was it 2.73 for the final answer last time?
1.5.
Yeah. No, anyways, this will be 0.6825 ohms. Is the answer.
Oh, you flip it.
I have to flip it.
Yes.
This is 1 over R. This is R.
Why is it different
No,
though?
it was the same idea, but I had different numbers in this question. This was a 200 kilometer, but I think the last one was shorter. Wasn't it? It wasn't 200 kilometers, was it?
It wasn't. It was 3. No. The length was 3 meters.
Yeah, okay. Well, no, that was the tree. The question...
No, it was 2,000.
2,000 kilometers?
Yes.
2,000 kilometers?
Yes.
My goodness, why did I make it so big?
No, the first one.
Yeah, it's a different question, but I wanted to show you the way you do it is different. So in the last homework, if this was not protected, then the resistance would be rho L over 2A, because the area is twice as big. But because it has a protection, then you have to do it this way, because it's like two separate parallel resistors. Yeah, now this one I don't think anybody... Did anybody get it? No. It was a little complicated.
So this number is 1.365.
This number?
Yeah.
Oh my goodness, I screwed it up. Sorry. Sorry. This is 1 over R, isn't it?
1 over 0.7.
Yeah, sorry, so I'm so sorry. So R should be... Flip that.
1.365.
Thank you guys. 1.465.
365.
Oh my goodness, what's gone wrong?
2.5.
I know what's gone wrong. I'm hungry. Add them together. Reciprocal.
2.73 over 3.
Oh yeah, sorry. 1.365. Yeah, finally. Okay. Right, next one. Oh yes, interesting. Okay, can I go down? Yeah. When two resistors are connected in series, the total resistance is 3. And when they're connected in parallel, it's 2 over 3. How big is each resistor? So this one's interesting. When I connect these in series, the total resistance is 3 ohms. But then when I connect them in parallel, it's 3 over 2 ohms. Did anybody get this?
Yes.
Yeah, good.
I think so.
So, what would we call this one? OR1 and OR2 maybe? Or X and Y? What did you call it?
R1.
Okay, and this is OR1 and this is OR2. So, in the first one, you know that OR1 plus OR2 should equal 3. And in the second one, you know 1 over OR1 plus 1 over OR2 equals 2 over 3. Good. Now, the big question is, what to do next? Substitute, very good. So we can say OR1 equals 3 minus OR2. Sub it in. So we get 1 over 3 minus OR2 plus 1 over OR2 equals 2 over 3. Now, we want to... Well, what did you do next? There's two things you can do. So
You can take the common.
yeah, that's one way to do it. Is that what you did?
No.
What did you do?
I didn't do the substitute. I kind of just imagined that if it's R1 and R2 is 2 over 3, and R1 total R is 3, so it's 3 minus 2. That's R1, and then I thought R2 after that.
Oh, so you tried to figure out the numbers in your head.
Yeah.
Okay, let's do it mathematically because they're not always going to be easy numbers to work out. So what I would have to do here is put these together. I could multiply everything by OR2. So if I put an OR2 here, here, and here, then these will cancel.
Yeah.
And then I should multiply everything by 3 minus OR2, 3 minus OR2, and 3 minus OR2. So then it cancels here and here. So I'm left with OR2 plus 3 minus OR2 equals 3 minus OR2 times 2 over 3 times OR2. I know it's a bit messy, but I'm just multiplying to get rid of the denominators. So now I have OR2 plus 3 minus OR2. Now if I multiply this by this by this, I get 3 times 2 over 3, so I get 2 OR2. And then if I multiply this one by this one by this one, minus 2 over 3 OR2 squared. Yeah? It's a bit messy. 2 over 3 OR2 squared minus 2 OR2 plus 3 equals 0. I'll multiply by 3. 2 OR2 squared minus 6 OR2 plus 9. My goodness, I hope this has solutions. Wait, I made a mistake.
Yeah.
Where?
5
I
to...
did make a mistake.
Do it by the LCM simple.
5 2 and 2 of 3. I
Two-
think
Here?
2, yeah.
Ah, because it's 1 over 3 over 2.
No, the first one is R is 2 over 3. So
1 over R is 2.
Here? Is this the problem?
Yeah.
can I see
3 over
the... Can I see
No,
the
but when it comes to parallel, so it will be.
R is 3 over 2.
Ah!
Yeah.
I wrote this wrong.
Yeah.
So
Alright, so this should have been 2 over 3, which just means this one then is
3 over 2.
3 over 2. Thank you, that's why that didn't work. Right, so I'll just fix that up. That one is 3 over 2. This one is 3 over 2. So I need to redo this. Right, I have R2 plus 3 minus R2. 3 times 3 over 2 times R2, that's now going to be 9 over 2 R2 minus, and then this one times this one times this one, 3 over 2 R2 squared. Right, again, these still cancel though. So it's 3 over 2 R2 squared minus 9 over 2 R2 plus 3 equals 0. So this time I should multiply everything by 2. 3 R2 squared minus 9 R2 plus 6. Oh, and now I can divide everything by 3. R2 squared minus 3 R2 plus 2 equals 0. What are the roots here?
6 and 1.
6 and 1? 2 and 1. R2 minus 1, R2 minus 2. So you get R2 equals 1 R2, which means then R1 equals, remember, if we go back to the start, R1 is 3 minus R2. So 3 minus 1, 2. So this is your first answer, or your second answer is, which is the same thing, 1 and 2 or 2 and 1, it doesn't matter. So the answer is one resistor will be 1 ohm, and then the second resistor will be 2 ohms, or vice versa. Yeah, a little hard for sure. Okay, is there another one?
Yes.
Yeah, okay. Alright, we have a diagram, or 1, 2, 3, and then is this, I can't quite see, that's E and E, and E is 6, and this is 2, 3, 4, okay. So, this and this together is 6.
No, it's 12.
Each one is 6.
Yeah.
Oh, each one is 6. Thank you. 12 volts. And then this one here is 2. And then this one up here is 3. And then this one here is 4. And what do I want? I want, firstly, what is the voltage through R1, 2, and 3, and what is the current? Okay. So, this one here will have a current, we'll call it I1. This one here will have a different current, I2, and this one here will have a different current, I3. Likewise, this one here will have a voltage V1. And both of these will have the same voltage, which we'll call V2. It could be. Now, what am I saying? Oh yeah. So actually, I know that V1 plus V2 should equal V, yeah, which is 12. Yes. Okay, so that's good. It's a start. Still have lots to do. Now, I think I'll add these all together to make it as 1. Yeah, so I'll do this on the side, okay? 1 over 3 plus 1 over 4 equals 1 over, I guess you can call this
7.
4. Yeah, so what's it? 1 over 3 plus 1 over 4, 7 over 12. So that OR is 7 over 12.
12 over 7.
12 over 7, sorry, 12 over 7. But we also have this 2 here, so I'll just add the 2. 26 over 7.
3.71, whatever.
Yeah, 3.7, yeah. So that means here this is about 3.7. That's great, because it means I can get this current here. because I can use my VIR. So I equals V 12 over 3.7, yeah. Yeah, if you want it exact, it's 42 over 13, or that's roughly 3.23, like you said. Amps. Yeah. Now, which one of these I's is that?
1.
Yeah, very good. It's actually 1 here, because what's happening is you have 3 amps coming along. This is still 3 amps because it's in series. So the current here and later is the same if it's in series. When is it different? Parallel. So it changes here. So we know that I1 equals 3.23, but we know that I2 plus I3, these combine back together here, and that still has to make the 3.23. Right, so we're building some equations. So we have 1, 2, 3. Let's make some more. Let's use the VIR triangle here. So what do I know? I want the V1. So I can say V1 equals I1 times R. So actually, you can know what the V1 is. It's just 3.23 times 2. So what's that? That's 6.46 volts. But now that I know the V1, can I know the V2? Yeah, because V1 plus V2 should equal 12. 12 minus this, I get V2 equals 5.54. And what's the V3? Well, that's the same, isn't it? These both voltages here are the same. I have I1, I have V1, I have V2. What's left? I2 and I3. So, if I know I2, I can get I3. Let's look at I2. Do I know the voltage? Yeah. Do I know the resistance? Yeah. So the I2 is V over R. What's the V? 5.54 over 3. So then the I2, 1.85 amps. And now can I get the I3? Yeah, again from this one. So then I get I3 is 3.23 minus that answer, 1.38? No? 3.23 minus 1.85. 1.38.
I did it differently.
But you got the same answers?
Yeah, same answer.
Fantastic. So what way did you take it then?
I got the total current.
Yeah?
And then I got the total, I separated it. I got each current by itself.
Yeah, but you need to know the voltage to do that.
I got the voltages by using the total current.
Ah, but the voltages are different for each.
Yeah, well, 2 and 3 are the same. One is...
Oh yeah, 2 and 3 is the same.
Yeah, so I multiply the total current.
Yeah.
By 1.7 the total resistance.
Yeah. And what did that give you?
I got 5.523.
Okay.
The total voltage. Then I timed that by 3 and 4, which is the R2 and R3.
Yes.
I got 1.38, 1.84. That's I2 and I3.
Which is the same.
Yeah.
Okay. Okay, that's fine then. That's fine. And there's probably other ways to break it down as well.
So how to get the total volt?
What do you mean? Oh, the V1.
The first question.
Yeah, the 12?
Yeah.
Ah, the 12 is in the question. I tell you that where's it gone?
No, the A. What is the voltage through R1 and R2 and RC? How did you do it?
But this is V1 and V2 is what I wanted.
In A.
Yeah. I did this part, I kind of just did it all together. I wanted all the voltages and all the currents.
No, the answer of the question A is equal 12?
No, the answer for question A is, where is it gone? This one,
Yes.
the first one, and this one. This is for A. When I said here, what is the...
How did you get it?
Oh, no, don't say that. Because everything here is how I got it. So I need one
From the
particular...
start, I don't know.
But you should have stopped me as I was doing it. When you heard something you didn't understand, you should have stopped me. So what do you mean you don't understand from the start?
And tan V1 plus V2 equals 4.
Good.
Yes.
So you understand this. Fine. Now, the next thing I did, what was the next thing? I got this.
How?
Wait, I'm about to tell you. Please. So what I did was I got the total resistance. Do you know how to get this? You add these together, yes?
Yeah.
And you get this. Yes or no?
I did it by...
No. How? I add these together to get this.
But it's in parallel. How to add them?
How to add them in parallel? You know how to do that. Here. Add these together to make this number. And then it's in series, so you add 2. And I get this number.
But I do it like 12 over 3 and it's equal 4
12 over what?
over 3.
12 over 3.
Yeah. For the first one. To get the current.
For this one?
Yeah.
12 and 3. Because you're saying V
Yeah.
over R. The V here is not 12. This voltage plus this voltage makes 12. If you remember, when they're in series, the voltage here and the voltage here are different. And when they add together, they make the total 12. So you should not use 12 here.
Okay, what is?
Because you write V1 and V2, it must be V2, 3.
Okay, fine. If you want a 2, 3. I'm going to do this again really quickly, and you're going to tell me what to do. Okay, so first one here, and then here. Right, this is 12, this is 2, this is 3, this is 4.
Yes.
Happy?
Yeah.
Right. This is an I1. This is an I2. This is an I3. And this is a V1, this is a V2, and this is a V3. Now you're happy? Yeah. Now, these are in parallel, so what do you know about their voltage? Equal. So V2 equals V3, because they're in parallel. And the total here, what's the total? V2 or V3. Everything here is the same. Everything's the same. Okay?
Yeah.
What's the voltage here? V1. And together, if you add this one with this one, the total should be 12. So you can say V1 plus V2 equals 12. Or you could say V1 plus V3 equals 12 because they're both the same.
Yeah.
Alright, so which one will we use? The first one? Yeah? Okay. Now, what you should do next is you should add all of the resistors together. So it's 1 over 3 plus 1 over 4 gives you 1 over whatever. Is it 7 over 12 here?
Yeah.
That's how much resistance you have here. And then you should add 2 because it's in series. So you get 12 over 7 plus 2, which is 3.71. So we want the I here. We have V, we have I, we have R. Are you awake?
Yes.
Okay.
I need to wash my face.
Go ahead. V over R. Right. What's the V? Here. 12. And the R? 3.71. So do you know I1? Do you know I1? Yeah, you know it here. Yeah? Yeah. So I won't repeat everything, I'll just do the steps. Now we know I1, and because we know 2, We know these two. Can I know this one?
Yeah.
Yes, I can know this one because I can use my VI or triangle.
Yeah.
So I know this, so now I can know this.
Multiply together.
Yeah. If I know this, and I know the total is 12, can I know this one?
12
Yeah.
minus 12.
Yeah, because I know that this one plus this one should make 12. So now I know the V2. If I know the V2,
I
yeah.
know the V3
But
because
the I are okay.
It's okay, is it? Yeah, yeah. Alright. What was I saying? Yeah, so I know the V2. Do I know the V3? Yeah, because of this.
yeah.
So if I know the V2 and I know the V3, and I know the OR and I know the OR, can I know the I and can I know the I?
Yeah.
Yes. And also, these two I's, when you add them together, they should also make I1. What are you doing? Is this one okay for you?
Yeah.
Are you sure?
Yes.
Right.
It's just complicated.
The I in V over R equals 12 over 3.71.
Yeah.
Where is it in the diagram?
In this diagram up here, it's the current here.
All of the current?
Yes, the total current, which is I1. Because it's I1. Yeah.
I1 is series. So
I1 is series. Yeah. The I1 is the total. And then the I1 then splits into I2 and I3. But then at the end it comes back together to make the total at the end here as well. So the I1 is the total. It's the same as the total. Yeah? Because remember, current is the same in series. So the current here will be the same as here because they're in series. It's only different when they're in parallel. Now don't you worry, we have lots more of these to do and more difficult. But I'm going to show you, I wonder if it's the next lesson actually. No, not yet. In lesson number 8, we have these very useful rules called Kirchhoff's rules, and these make using Kirchhoff's rules in lesson 8 make these problems much easier to do. Okay, so if it's a little difficult, that's okay. We are going to do more difficult questions in lesson 8, but because of Kirchhoff's rules, they actually become easier. So in lesson number 8, you'll love it. It'll be things like this. You have one going this way, and then you'll have one going this way, and then there'll be one here, and there'll be one here, and then there'll be another one here, and then they come back together, and then there's one here, and then it'll go like back up here, and there'll be one here, and there'll be another one here. You'll love it. It'll be great. No, because these rules, I don't know if you've heard of them before, Kirchhoff's laws.
know the name.
You know the name? These are very useful rules to simplify these problems, okay? So it's difficult. We'll do more difficult ones, but it will get easier, okay? So let's have a look at the next. Was that the last one?
Yeah.
Yeah. So I promise you, you can watch this video again and hear my promise. I promise you, later when we have more difficult ones, this will seem so easy you won't even think about it. Okay? Right.
If it's in the exam.
Oh, it's a great question for the exam.
Oh no.
It's
I mean,
yeah.
I have to write question A and then question B, or I put it together.
You should write A and B. But sometimes, sometimes you can put them together as long as you make your answers clear. Not like me. If you make your answers clear, it's okay. Yeah. Here, look. I'll show you some great Kirchhoff diagrams here. Let's see. You'll love them. You'll look at them and think they're great.
It will take how much time?
Oh, no, they're great. It's actually my favourite question in the exam.
No, to open it.
It should have just only taken a here we go. Well, this one, we've seen before. Oh, look at this. Look at this. You got battery, and then 3 resistors here, and then we have this one, battery, or cell and cell, and then, yeah, nice, yeah. I don't know why that's in there. That shouldn't be there. Alright, so let's go on to the next lesson now.